Hi, my name is John, and I will be going over Mr. Allman Module 4 quiz. It's a redo from Buena High School. Okay, so the quiz is going to be on graphs of inverses and as well as with charts, exponents, the rules of engagements for those. What are the rules for exponents and evaluating? I'm going to give some examples. Also, we're going to be simplifying expressions such as 1 plus 2i times 3i minus 4 and 3 square root of 2 plus 3 square root of 7 plus 2 times 2 square root of 5 minus 3. So let's get at it. And here's the next one right here. I graphed it for you. I know it's a little bit upside down or on the side. I'm actually going to do it this way so that you can see it a little bit better. Take it out. Let's graph the first one. It says something like this. Graph this is the y equals x line. It's a 45-degree angle going through the origin right over there. Okay, and I actually created this point for you. Here's your x, here's your y. It's going up, going to the right 3 units and up 8 units. Each of these are 5 units, so this would be 10, up 10. Okay, so I actually labeled these so it'll be easier for us to work on. What we do is I'm going to use green pen. Just reverse the 3 and the 8. So according to the y equals line, the image of that is 8 comma 3. So we go 8 units here and up 3 units. That's A prime. I'm going to label that 8 comma 3. C prime, let's do B prime first. It's not negative 9 comma 4, negative 9 up 4. So it's going to be 4 comma negative 9. 4 and then negative 9. And that's B right there, prime, which is 4 comma negative 9. And let's look at C prime. Negative 2, negative 3 is the coordinate. So it's going to be negative 3, negative 2. And it's going to be right there. I'm going to call that C prime, which is negative 3 comma negative 2. And what we're going to do is just take a ruler. I have a ruler with me right here. And we're just going to connect the dots. Remember that? Kindergarten? Connect the dots. And here we go. Here's B prime. And here's, and right over there, that's C prime right there. Okay. So it looks like this blue image, if you take the image of that, this is the pre-image, this is the image, and it looks just like a mirror image from y equals x. So what we literally did was, first thing you have to do is find the coordinate of that point, and then just reverse it to x and the y. Okay. Let's do the second one right over here and see how that goes. This is y equals x cubed, a function. And what I did was I plotted 1, 2, 3, 4, 5 points. When you plug in 0 for x, you get 0 for y. There it is. If you plug in 1, 1 cubed would be just 1. 1, 1. And if you plug in 2, what's 2 cubed? It's going to be 2 times 2 times 2, which is 8, not 6. It's 2 cubed. And so I tried negative 1 and then negative 2, negative 8 as well. So I got those points. We do the same thing. I'm going to use, should I use some other color? I believe this color is called cayenne. I'm not quite sure. No, let's use purple. So 1, 1 is located right there. 2, comma 8 becomes 8, comma 2. There it is. 8, comma 2. And negative 1 stays there as well. And negative 2, negative 8 becomes negative 8, negative 2. And there it is. And so it's going to go through this point right here like this. If you look at it, the purple line looks like a spitting image of y equals x cubed. Okay, that's the second page. There's only 5 pages. A couple more pages to go. Okay. So if you are given a chart like 2, comma 3, or we can write it 2, comma 3 as well, or 3, comma 5, 4, comma 7. How do you find the f inverse using the coordinate? You just switch the x and the y. So easy, right? 3, comma 2, 5, comma 3, 7, 4, and that will be your answer. Okay? So if they give you a coordinate, it says find the f inverse, the coordinate would be just switch the x and the y. Just like this form right here. Remember, we switched the x and the y. 3, 8 becomes 8, 3. Okay? Rules engagement for exponents. Before we do that, what is the definition of a to the x? I'm going to use black. No, let's use green here. A to the x by definition is a times a times a dot dot dot, and you're going to have x factors of a. That's the definition of a to the x. So let's try 5 cubed. Well, using the definition, we use 5 times 5 times 5, which is 5 times 5 is 25, times 5 is 125. Okay? So let's look at the rules. When you have a to the x times a to the y, there are there are x factors of those, and then times a all the way up to y factors, and you have total of x plus y factors. It would be a to the x plus y. A to the x raised to the y, it would be a to the x times y. And a to the minus x, this negative, to make it positive, we do not bring it down to the front. Never ever bring it down to the front. All we do is rewrite 1 over a to the x. And of course, a to the x over a to the y, if this we add the exponent when the base is the same. When the base is the same, we subtract the exponent, x minus y. Let's look at some examples of how we do this. You could have done 5 times 5 is same thing as 5 squared times 5 times 5 times 5, and you end up with 5 factors of 5, 5 to the 5th. Or what we could have done was just added the exponents. 2 plus 3 is going to be 5 right there. Okay. How about this one? We could use the definition. 5 squared times 5 squared times 5 squared, which is 3 bundles of 5 squared. You end up with 6 bundles. Or we could have just, by definition, 3 bundles of 2 is same thing as 3 times 2, which is 6. Or we could just multiply these two. So when you have a power to a power, we just multiply them. Okay? How do we do something like this? Well, this is same thing as 2 times a to the minus 3, right? Because these are factors. They're being multiplied. So this becomes the 2 stays in the numerator, and a to the minus 3 becomes a cubed. Be careful on this. The 2 does not go to the denominator as well, unless it's the whole quantity. Okay. How about this guy? How do we do this guy? We could have done 5 squared minus 5. So we could have subtracted, and that becomes 5 to the minus 3, which becomes 1 over 5 cubed. That's one way to do it. We could have done it this way as well. I'm going to write it up here. 5 times 5 over 5 times 5 times 5 times 5 times 5, right? There are 2 factors, so we can cancel those 2. You end up with 1 over, there has to be a remainder of 1, and then 5 cubed. Okay? So that's how you do that question. Okay, so how do we do something like this? Negative 1 to the 4th. It's the same thing as negative. There's a parentheses just around the 1. There's a hidden parentheses. So it's negative 1 times 1 times 1 times 1, which is negative 1. This does not equal negative 1 to the 4th, which by definition means negative 1 times negative 1 times negative 1 times negative 1. Negative times negative is positive. Negative times negative is positive. So you end up with just positive 1. You can use it on your calculator as well. If you go something like this. Negative 1 exponent 4, and you end up with negative 1. Okay, if I go quantity negative 1 to the 4th, I end up with positive 1. Okay, all right, so we're on third page. There's only 2 more pages to go. We know by definition that square root of negative 1 is by definition I. If we square both sides, square this one, we get this, right? And because they are inverse operation right here, square and the square root, you end up with just negative 1. We know that square root of I squared is negative 1. Make sure that when you're doing this, you're on the, if you're using the TI-84 plus calculator, make sure you're in the A plus BI mode, which is located right there. Okay. If you're in the real mode, it won't work. Okay. So your i's right above your dot right there, and I'm just going to square it. There's a square button right over there. You press it, and you end up with negative 1, of course, right? So what is negative 4i squared? Let's do an example. I'm just going to put negative 4 times I squared is negative 1, right? Which is just positive 4 now. Negative times a negative is positive. Okay. What about this guy right here? So what you notice that is a shortcut would be crossing that out and changing the sign. Okay. So let's use a shortcut. I'm going to use a different color. I'm going to take that square and change the sign. Equals negative 25. If you have 2 i's and you have another I, you end up with, you have 3 i's. Who has 3 i's? I'm not quite sure who has 3 i's, but still, you end up with 3i. So those are some rules of engagement. Let's do this one right here. 2i minus 1 times 3i plus 7. You're going to fold it out. First, outer, inner, last. Let's just write it out. It's going to be 2i times 3i. 2i times 3i. The outer, those are the outer, 2 outer ones. 2i times 7. The 2 inner one, remember the minus goes with the 1, right? So it's negative 1 times 3i. And lastly, minus 1 times 7. Let's just evaluate this. 2 times 3 is 6. I times I is I squared. You have 6i squared. 2i times 7. 2 times 7 is 14. You have an I left. Negative 3i. And minus 7. Negative 1 times 7 is negative 7. Okay? Make sure I went a little bit fast on these, so you need to slow down when you're working on these. Alright? I know that 6i squared is going to be minus 6. Yeah, plus 49 minus 3i. So you end up with negative 6 minus plus 49 minus 3i is going to be 11i's. Plus 11i. Remember, it's plus positive because 14 minus 3 is 11. Minus 7. And we add like terms. It's going to be negative 13 plus 11i. Let's check it with the calculator. This does really good job in terms of figuring out what is the word? Calculating i's. So we write it straight out like this. Where's the problem? There it is right there. Parentheses 2i. Where's my I? Minus 1. And parentheses times 3i. Oops. 3i above my dot plus 7. I don't need to put end parentheses right there, okay? Negative 13 plus 11i. Negative 13 plus 11i. Check. I want you to do this one by yourself at home. Figure it out. Check it with the calculator. And hopefully it'll check out. Okay. Last question. Distribution. Before we do distribution, here's some rules of engagement. Square root of a times b is the square root of a times the square root of b. You can separate those out. Square root of a plus b does not equal square root of a plus square root of b. You cannot do that. You cannot separate them out because these are two different terms. Let's simplify some radicals here. What I like to do is this is the way I teach my students. I like to branch it out. I need to find the perfect square that's a factor of 18. Again, I need to find the perfect square number that's a factor of 18. So it's going to be 9 right there. That's the key. Times 2. And then what we do is we square root both of them. And the square root of 9 is 3 square root 2. Let's try another one. I branch it out again. What's a perfect square that's a factor of 12? It's going to be 4, right? 4 is a factor of 12 times 3. And then what do we do again? We square root both of them. I like to put the perfect square first. That way it comes out nice and easy. 2 square root of 3. Square root of 8 is, branch it out again. It's going to be 4 times 2. That's a perfect square. And then square root both sides. Practice these. It's going to get easier. 2 square root of 2. I'm just going to check one of them with you, okay? I know that square root of 8, where's the square root of 8? It's going to be approximately 2.828. There it is right there. If I take 2 times the square root of 2, I should get exactly the same answer down to the last digit. And there it is. Okay, got it? So let's try simplifying some of these first. First of all, square root of 18. Oh, I already did it. 3 root 2. Plus 2 root 3 times, root 12 was 2 root 3, right? So what is 3 times 2 root 3? Always multiply the outsides, okay? It's going to be 6 root 3. Minus, I know that root 8 was 2 root 2. 4 times 2 root 2. This is root 8. I got it from here, which is here. 4 times 2 root 2. Substitute. You end up with 8 root 2. So we're going to FOIL it out first. First is 3 root 2 times 6 root 3. Outer, the two outer ones is minus. There's a minus right there. 8 times 3. I'm sorry, I'm just going to write it out. 3 root 2 times negative 8 root 2. The two inner ones right over here. Sorry for my lazy penmanship. 2 root 3 times 6 root 3. And lastly, oh geez, 2 root 3 times negative 8 root 2. Okay. Oops. Okay, so what do you get? 3 times 6 is 18. Root 2 times root 3 equals root 2 times 3. Remember, you can go on the, if it's this way, you can go backwards to one single radical, okay, which is root 6. I multiply these two. That's going to be 3 times negative 8 is negative 24. And what's root 2 squared, right? Because root 2 times root 2 is root 2 squared. That cancels. Remember, these are inverse operation. You end up with just 2. Okay? And let's use 2 root 2 times 6 is 12. Root 3 times root 3 is just 3, right? Remember, the inverse operation, root 3 squared is just 3. Okay? Let's try this one lastly. 2 times negative 8 is negative 16. Root 3 times root 2 is root 6. And let's clean this up a little bit. 18 root 6. There's a minus. 24 times 2 is minus 48. With a minus right there. Sorry about that. Plus 36. Minus 12 times 3 is 36. Minus 16 root 6. We can add like terms. These are like terms. 18 root 6 minus 16 root. No, these are not like terms. Oh, these are like terms. I miswrote it. Sorry about that. What's a root 6? So 18 root 6 minus 16 root 6 is 2 root 6 minus 48 plus 36 is minus 12. Create some problems and work on them, and hopefully this will be enough for your quiz so you can do a really good job. Good luck, girls.